In this lab, we will continue with developing models using uh, classification trees and for biodegradable data. So we import the library tree to do that. So we fitted a really large unpruned classification tree to the training data, and then we found the misclassification error rate for the test data, and the misclassification error rate for the test data was for 0.05123334. Then we pruned the tree using the cost complexity, using the best cost complexity. So the way to do that is that we found the minimum deviance and we found the index for the minimum deviance, and that index, for that index we found the cost complexity, which is also chi, and using that cost complexity we pruned the tree, the model, uh, so that gave us the prune tree. So, and then we calculated the error rate for the test data set, and we can see that the error rate was, the misclassification rate was higher of 0.1214421. Now in this lab we will consider pruning the tree using cross validation with misclassification rates. Deviation represent the number of misclassified observations. So to do that, we pass the command set seed of 1, 2, 3, 4, 5. Then we use cross validation with misclassification rates. Let cv.r1 equal cv.tree of fit, comma, method equal misclass. So that gives us the size, the deviation, the cost complexity, the method, and the attributes. In the following code, we select a tree size location of the simplest model for there is more than one location of minimum deviance. So this code here. So cv.r1 model at deviance equal minimum of cv.r1 at deviance, and we can see that and then when we put that in bracket and write which outside the bracket, then it gives 4, 5, 6, 7. So that's 179. So 179 deviance is the minimum, and the index, the position of it, the location of it is 4, 5, 6, 7. Then we select the location of size of the simplest model. So we select the maximum location. So we pass the command j.minimum equal to maximum of which of cv.r1 at deviance equal minimum of cv.r1 at deviance, and that will give us 7. Then cv.r1 at size and bracket j dot minimum. J dot minimum is 7, and we look at the size but for the index 7. So 1, 2, 3, 4, 5, 6, 7, and that's 36. So the size is 36. Let size equal CV dot R1 at size of a square bracket j dot minimum, and that is 36. In the following code, we produce a prune tree by tree size. So tree pruning based on the best size. Let fit2 equal to prune.tree of fit, comma, best equal size, size is 36, comma, method equal misclass. So we get this. So we have the root of 1055 rows. Then the child of it is SP max BM less than 3.6775, and the child of that is F02CN less than 2.5, and the child of that is SP max L less than 4.984, and the child of that is N0 less than 1.5, and the child of that is SM6 BM less than 8.2405, and the child of that is SP max L less than 4.7965, and the child of that is NCP less than 0.5, and the child of that is C less than 41.45, and the child of that is MI less than 1.131. And on the right we will have MI greater than 1.131. Okay, and so on. In the following code, we plot the prune tree selected by size has the parameter value. Plot fit2 text of fit2, comma pretty equals 0, comma CEX equals 0.4. So we get this. Comment: the plot shows less internal nodes compared to the unpruned tree. It has more internal nodes compared to the pruned tree by selecting a cost complexity parameter value. So the cost, the tree which is pruned by using the cost complexity parameter value, that tree looks have less internal nodes compared to the prune tree from size. In the following code, we compute the training and test errors for this prune tree using the errors function. So call the errors function of on fit2, the inputs are fit2 model, comma fhead.tree, that's the function, comma train, comma test. Now the test error is 0.0626186, which is less than the test error from prune tree by selecting cost complexity, but bit more than the test error for the very large unpruned tree. So do you think the pruning helps? Training dataset is unreliable to use for comparison as it is biased, so we will consider test dataset error for comparison. Pruning helped in finding a simpler model, but the misclassification error rate is a bit higher compared to that of unpruned tree. For the unpruned tree, the test set error is 0.05123334. After pruning by selecting a cost complexity, the test set error is 0.1214421. After pruning by selecting a tree size, the test set error is 0.0626186. We conclude that pruning by selecting a tree size has helped in getting a slightly simpler model than the unpruned tree, but the misclassification test error rate is slightly higher. Comparing to selecting by cost complexity, the test error rate is lower.